What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
One of the simplest but brightest examples of successful use of chip tuning is to increase the idle speed. Why do it? It's no secret that cars are built a little strange nowadays. First they set the ecological system and then they invent the engine. And everything else for it. Reduction of idle speeds is something from the category of the second circuit EGR, AdBlue and other attempts of green on the sound design thought. The meaning, in general, is clear: the lower the idle speed, the lower the amount of exhaust gases in this mode of engine operation. And therefore, the higher the ecological class. Another thing is that at very low RPM it is difficult to reduce COCH emissions, so they raise the engine operating temperature and at the same time fight with warm-up speeds, but this is discussed below. What's wrong with low RPMs? Let's start with the fact that it is simply uncomfortable. The car shakes, and when there is a resonance with some large metal and plastic parts, especially with interior parts, it becomes very uncomfortable inside the car. And if the driver and passengers can somehow survive it, then some mechanisms to this shaking are sharply negative. For example, filled motor and box supports, which quickly get tired of damping abnormal vibrations and fail much earlier, and their prices are often staggering. The shaking rubs the insulation of underhood wiring, connector contacts are broken, the resource of quick-release connections is reduced, rubber and plastic lines of the cooling system, crankcase ventilation system, exhaust gas recirculation system and other systems with similar elements wear out earlier than expected. In short, unnecessary vibration is harmful. And it is necessary to fight it. Or maybe we shouldn't. Opponents of raising the idle speed have several objections to this operation. The first objection is quite logical: you don't want the car to consume liters of gasoline or diesel while standing still. In fact, this will not happen. Judging by onboard computer readings of those cars where such operation was performed, the consumption grows insignificantly. For example, if with factory software it is 0.8 liters per hour, then after revs rise it will increase to 0.9. It is not essential, and certainly it will cost less than to change a torn hydraulic support or motor braid of wiring. The second concern is not so obvious, but also has the right to life. The point is that any modern, and not so modern, car can raise the revolutions to the necessary level if necessary. For example, when switching on some additional load in the form of heated windows, mirrors and seats, or when switching on the air conditioner. ECU can raise the revolutions at increasing load on the pump of the power steering, at active work of the fan, or fans of the cooling system, at the request of the control unit of the automatic transmission. In short, there are a lot of such situations, and ECU itself knows when the idle speed should be raised. Will it not happen that after reflashing these revolutions will be too high if the engine control unit starts to raise them from the already increased idle revolutions? No, it will not work that way. The thing is that the values of these revolutions in most cases are not set additively, that is, ECU raises them not by some value relative to the idle speed, but to some predetermined value. So the car will not overexhaust when the climate control is switched on. But it will not shake in fever at every stop at a traffic light either. In short, there is no need to be afraid of this procedure, there is no harm from it. It is recommended for some cars, e.g., Kia, Hyundai, Suzuki, Infiniti and some Renault and Nissan products. It can also be useful for cars with variators. Here, low idle speeds are sometimes the source of problems with low starting oil pressure. Too hot to live. The second problem, which can be solved by chip tuning, we often mention in materials about modern cars with mileage. Unfortunately, very many current motors are too thermally overloaded. And this reduces their service life. High temperature is imposed on them from the same ecological point of view. It is necessary for maximum combustion of COCN, although the catalytic converter actively fights them. It is true that at high temperature and poor mixture, as it usually happens on a modern engine, the content of nitrogen oxide NOx increases in the exhaust gases, but EGR is designed to fight it. but, as I have said many times, the battle of ecological systems is endless and there is no escape from it. Let them fight as much as they want, but to ruin the engine with too high temperature is too much. It's not worth putting up with. I think there is no point in describing the danger of high temperature. In short, all plastic and rubber parts age quickly, cooling system elements fail, and plastic pumps and spigots can fall apart. The motor cokes quickly and starts to consume oil. In short, nothing new, just a lot of unavoidable evil. Or avoidable. There are various ways to reduce the motor temperature. For motors with an electronically controlled thermostat, the method is obvious: change the opening temperature of the thermostat. However, there are many pitfalls. ECU must realize that the motor is warmed up, and henceforth its operating temperature, for example, not 105 degrees, but 95 degrees. So in the software will not be enough to change one digit, as some tuners believe. It is necessary to know how to change the temperature, but, unfortunately, few people think about it. On simpler motors without an electronic thermostat, the temperature can be lowered in another way, by changing the algorithm of switching on the radiator fan. It is possible, of course, to put a cooler thermostat, but today we are talking about chip tuning. In addition, the ECU may look too suspiciously at the work of the motor, which suddenly stopped warming up to operating temperature. So that a change in software for a competent reduction in operating temperature is almost inevitable. Who should think about this procedure? For example, owners of GM cars with motors A16XER, Z16XER, A16XHT, A18XER, Z18XER, A14NET, NEL. In general, it will be useful to anyone who drives Opels and their derivatives. The main problem with these motors is that they flow from wherever they can. Where they can't, they leak too. And it's not just the failed heat exchangers, it's the hot temperament. This procedure is also very useful for all new Mercedes gasoline engines and especially for BMW and series engines, including the joint creation of BMW and PSA in the form of Prince series engines. And it is better to carry it out in advance while the motor is still alive and not finished off by a cruel thermal regime. But on diesel engines this procedure has no sense. Diesels do not warm up like this. What else? Of course, the list of problems that can be solved by chip tuning is not limited to these two positions. But they are what I would call the main ones. They are the scourges of modern automobile construction, especially it concerns temperature regime. And if we talk about everything else, chip tuning is often useful, for example, when setting the stages of the electronic oil pump, which is very relevant for TFSI motors, to disable the start-stop mode that destroys the engine and start a generator, or adjusting the ignition advance angle. There are also more specific requests. Sometimes transportation companies ask to set limits to reduce accidents. Driving schools asked to raise idle speeds so that the student does not swallow at every attempt to start from a place, which, in my opinion, is not very correct. But these are still more private cases. But for owners of new VAZ cars, it makes sense to overcome one inborn disadvantage of the standard firmware: lack of normal warm-up revs. Very often in cold weather, immediately after starting the engine screams for the first few seconds. This is how the catalyst warm-up mode works, and then immediately drops the RPM below 1000. This is good from the point of view of ecology, but bad from the point of view of the driver, who finds it difficult to wait for the engine to warm up. As a result, the unhappy motorist is forced to follow the lead of marketers and start driving almost without warming up the engine. No matter what anyone says, but it is also harmful, and it is better to return the warm-up revolutions to their place programmatically. For help in preparation of the material, we would like to thank the company Laboratory of Speed Tuning Online. In conclusion, chip tuning offers a range of benefits beyond just increasing power. By addressing deficiencies such as throttle response, fuel efficiency, and overall drivability, car enthusiasts can enhance their vehicle's performance and enjoyment. Whether you're looking to improve your daily commute or maximize your vehicle's potential on the track, chip tuning can provide a tailored solution to meet your needs. Remember, it's not just about raw power, it's about creating a balanced and refined driving experience. Thank you for watching, and we hope you found this information helpful in understanding the broader advantages of chip tuning.